the frequency of the median class, and I is the class size. And for the example, we have the data shows that the time spent in Facebook by 43 students, find the median time and interpret the result. Okay, so given what we call the class interval and the frequency, all you have to do is to solve for the less than cumulative frequency. So we have there, okay, we will start to look for the less than cumulative frequency. We're going first to start with the lowest class interval, and that is 25, but with the given frequency 3. So you simply copy 3 and to obtain the second less than cumulative frequency of the second interval or the next interval. So we will add the frequency of the second class interval together with the first cumulative frequency. So we have 3 plus 2, 5. Okay, then we will just follow same step, and therefore we come up with the last less than cumulative frequency, which is equal to 43 for the last class interval. So we have our less than cumulative frequency is equal to 18, and the number of students we have is 43, that is n divided by 2, so we have 21.5, and we have our L is equal to, or lower class boundary, we have 44.5. Applying the formula, so we have now the value 46.69 is the median time spent by the student in Facebook. Okay, for the characteristic of the median may not be an actual observation. So meaning, we cannot find the value in the set the value in the data set. So may or may not be found. The value in the data set can be applied in at least ordinal level. In the major advantage, it is a positional measure and it is not affected by extreme values. And the major disadvantage is less stable than the mean. The mode occurs most frequently, nominal average, and we're going now to compute for the mode of the ungrouped data. Let us consider this what we call diagram. For the first diagram we have the sets of data. So 1 appears once, 3 once, 5 twice, 7 once, 9 thrice, 10 once, 12 twice, 13 once, 14 once. So we have now our mode is the number that occurs frequently, we have 9, so therefore the mode is 9. And for our second diagram, so the element of our data set, as what you have noticed, so we have 0 appears once, 1, 2, 3, so they are all 1, 2, 5, 6, so they appear once, therefore there is no mode, or the mode is equal to 0. So let us now proceed for the computation of the mode for group data. First, we have to know what is the modal class. The modal class is the interval that contains the highest frequency in the distribution. And the formula for the exact mode for group data, we have mode is equal to L, sub x hat plus d sub 1 divided by d sub 1 plus d sub 2, times I. Steps in finding the exact mode. So first, we're going to determine the modal class. The one with the highest frequency, and then get the value of d sub 1, get the value of d sub 2, and get the lower boundary of the modal class. And then apply the formula, substitute the value obtained in the preceding steps. Okay, so we have here an example. The data shows the time spent in Facebook by 43 students. Find the exact mode and interpret the result. Given the class interval and the frequency, okay, so we have the highest frequency there, we have 9. Therefore, our modal class, we have 55 to 59. The class interval, okay, well, this one will be our modal class because it has the highest number of frequency. Okay, for this sub 1, we have 9 minus 8. So the frequency of the modal class is 9. So we're going to subtract the preceding frequency, that is 8. That is why we obtain 1. And then, okay, we have for the D sub 2, so frequency of the modal class minus the frequency after, okay, the modal class. So we have 0. Therefore, we have 9. And for the, our lower class boundary, okay, to obtain that, okay, we are going to subtract the class, the lower limit of, okay, the modal class, 55 minus 0.5, so we obtain 54.5. So we will now apply what we call the formula. By applying the formula, so we have now our mode. The mode is 55. It means that majority of the students spend, okay, is 55 minutes in the Facebook. The mode, characteristic of the mode. It can be used for qualitative as well as quantitative data. May not be unique. May not be unique because, okay, there are some modes we call that when our data, the data may have one mode, therefore it's unimodal. If we have two modes, bimodal, okay, and okay, so if there is, okay, and also if the data appears once in the set of data, therefore it has no mode. So major advantage, not affected by extreme values. Major disadvantage, not ideal and may not exist. Okay, when are we going to use the mean? Okay, when something stability is desired and other measures are to be computed, when we're going to measures, okay, we're going to compute other measures. Okay, so use the median when the exact midpoint of the distribution is desired. And there are extreme observations. And for the use the mode when the typical value is desired and when the data set is measured on a nominal case. Okay, so to end this discussion, I have here the exercises to assess your knowledge. That ends my topic, and I hope that you learn and understand about measures of central tendency. Thank you for listening.